Now, everyone who loves physics. In this video, we'll be talking about some daily stuff which we are using and the application of physics in our day-to-day lives. A lot of times I'm getting this question that physics is something very difficult and it's not our cup of tea. I do agree. It's not a tea, it's actually a coffee, which is quite easily made. So I'll be simplifying physics. It's a request to all the students, those who are watching, and to all the viewers that please use your earphones if needed. So let us begin with the very first thing about physics. It's and as I've been telling to a lot of my students that before beginning with any topic, any session, or any subject, it's extremely important to understand that why are we studying this subject or topic. So that's exactly the thing that we'll be beginning from. That is, let us see why physics is important and how each and everyone is connected to physics in their daily lives. The very first thing is about when a baby is born and when the toddler is trying to just walk past the places, it is balancing itself, and that balancing is physics. Initially you might have observed that they are taking some sort of support to walk, but then after gradually they learn how to walk and run as well as jump. So the very basic thing, that is the balancing, which we are learning at a very tender age, that is nothing but physics. I'll show you one example of it, a very live demonstration of it. Just a minute. Okay, this is something which you already know. Now, just to understand, make you understand in a very simple words, let me show you some wonderful activity with it. Now, if I'm trying to balance it equally, then I'm able to get to the center and the racket is perfectly balanced, as you can see. Even if I move ahead, even if I move away, it's still very nicely balanced. So this is nothing but physics, the center of mass and the gravity. Say, for example, if I'm changing the whole scenario to a different case, if I'm moving only one of my finger, one of my index finger, then as you can see, it starts to imbalance a bit, and that's how you can see that it will gradually fall down if it is not balanced properly. Yes. So that is the daily life physics. No books are required to understand physics. It's around us. It's everywhere around us. It's in your pen. It's present in your pencils. It's present in your every day-to-day jobs, every day-to-day task that you do. If you are walking, it's possible because physics is present, which is nothing but the friction. So now I'll be unboxing physics as I had promised earlier, and I've received one wonderful present from C.V. Raman, Homi Baba, and his friends. So by now you must be knowing that those all of them were physicists, a very well-renowned physicist of India, as well as we are having Sir Isaac Newton and Albert Einstein, the great. So let us unbox physics. As you can see, I have literally got the box of physics, which will be unboxing it, since unboxing is in the trend. So why not? Now, as you unbox physics for your Form 9, you will be very first thing which you will be able to see is the force of friction, which is the thing that is used very widely. Now, the force of friction, as you might have understood in your Form 8, in your grade 8, in earlier stages, there are different types of frictions: kinetic friction and rolling friction. Sorry, kinetic friction and static friction. So the static friction is a friction which is present when the object is not moving, whereas the kinetic friction is present when the object is in motion. So that's the very basic thing about friction. In our day-to-day lives, if at all you are sprinkling some powder over your carom board, that's actually nothing but reducing of friction. So as I told, friction is everywhere, believe it or not. If at all you are replacing your tires after a few years, your tires of vehicles are completely worn out, and due to that, we are replacing the tires with the new ones. So that's also because of the friction present between the objects, the road and the tire. So it's getting worn out, and we need to replace it. So we'll see one simple activity about the friction, as well as about the next topic of ours, which is nothing but the motion. So let us begin with motion. Since you are aware of what is motion, anything that is moving or even stagnant, it is still a motion. There are different types of motions, there are different equations of motions, there are laws of motions, but you don't have to worry about that right now. I'm not going to teach you into details right now. Right now we are just going to enjoy some wonderful phenomena of physics. So about the motion, there is one interesting term, that is inertia. Inertia is basically, in the common words, if I say, it's the laziness. When you don't want to move, and if somebody pushes you, that's what the inertia is. You will not be moving very smoothly. So I'll show you one demonstration of the same thing, and this activity will require, which you might have seen, and this activity will require a glass, as you can see, a placard, and a coin. These are the things which you will require. Okay. Now, as soon as I'll be flicking the placard, then I hope you are already aware of what is going to take place. Well, so I'll just, without wasting any time, I'll just do it. When you just flick the play card, sorry, when you just flick the play card, the coin falls into the glass, and that's because of inertia. If I'm repeating the same thing slowly, then it will not be taking place. Let me show you once again. If I keep on pushing it very, very gradually like this, the whole thing will fall down and the glass is still empty. So this is nothing but the law of inertia, which you will be studying in your Form 9, grade 9. Let us observe what is for us in the box next. Well, the next thing is something that you are aware of since a very, very long time. You may have you might have seen the story of Sir Isaac Newton when you were young, when he was sitting under a tree and an apple fell down, and rest of the things you already have heard about it. He started thinking about it, that why did it fall down, and he did not, why the apple did not go up. So to demonstrate that thing, it's pretty simple. Whatever things you are throwing upwards, it's getting, it's again pulled back to the earth. So that's something which is already aware, you are already aware of. But yeah, definitely I'll be just passing on the ball, and let's see when it falls down. So yeah, the ball is gone. And now gravitation is a universal force. If you observe the whole earth, the whole earth is having gravitation, and because of which we all are staying at the place where we are. We are not going into the deep space. All credit goes to the force of gravitation, which helps us to be on the ground. It holds us on the ground, and that's what the gravitation force is about. That will be one of your chapter, and I am just introducing every chapter one by one. So yeah, that's what the thing is. And yeah, here we are having the ball back. The very next wonderful phenomena, or the topic about physics, is work and energy. You might have observed a lot of times your parents are saying it, that you need to do work, you need to do hard work. Well, those all things are nothing related to physics. In physics, work done is defined as how much displacement is done with respect to the force that has been applied. So that's what work done is. So suppose if you are just reading, or if you are just watching this video, that's not actually work done according to physics, because there is zero displacement. I hope you are not moving during the video. So that's zero displacement. And when the displacement is zero, that is known as zero work done. So such interesting stuff is going to come across your Form 9 syllabus, which is the fourth chapter of your Form 9. The very next thing in our box of physics is nicely made: electricity. Now, electricity is something that you are already knowing it. It can rock your world as well as it can shock your world. So many people might have already had some experience in the past where they got some sort of shock. So that is because of the electricity. The flow of electrons is known as electricity. Bit textbook thing in between, just in case. So this particular topic will be talking about how electricity flows, and what all equations of power are, how can you calculate power, how power and work done is associated with each other, and likewise. So this particular chapter is helping us everywhere in our day-to-day life, and that's the thing. Then after, in our box of physics, we are having the last thing as sound. Something which all of my Form 8 students might be knowing already very well. I hope you have not forgotten during this Corona time and the extraordinary situations what we had studied. And I'll recommend you to refer it if at all you've forgotten. So sound is something that everybody knows what the sound is. It's an energy by which we are able to hear. And right now, whatever I'm speaking, you are able to hear all because of sound and a couple of other technologies. So sound is made up of vibrations, and vibrations are any to and fro or back and forth motions. We produce sound by various ways. We can produce sound with the help of a very common thing, the whistle. We can even make sounds by just clapping it. So sound, we can produce sound by various ways, and obviously larynx or the voice box is one of the major source of our sound. This sound is again something that we are learning at a very, very young age. Whenever at a young age, when a baby needs something, it produces some sound, basically crying. And that's how we are learning various means and ways to produce sound. Sound is very, very important for communication. And although it is not the only medium of communication, but it is one of the major source of communication. It makes our world very easy. So in this particular topic, you will be talking about the how the sound is produced, where does the sound travel, how does the sound travel, speed of sound, and also the applications of sound. If at all you heard the word about ultrasonic frequencies, infrasonic frequencies, supersonic frequencies. So those ultrasonic frequencies will be used for a certain amount of the applications, by which we'll be able to clean the things. We'll be able to go, we'll be able to know how much deep the ocean is, which is known as the sonar system, sound ranging and navigation. So these are the things which will be included in the chapter, along with some few things about the animals, like the bats. It's very dangerous to talk about bats at the moment, but we are not talking about just eating the bats. Bats are using echolocation. They are producing sound frequencies, and then when the sound is reflected back, according to that, they are able to navigate their own way. So that's known as echolocation. So a couple of other interesting things are going to come. Again, the structure of human ear will be coming, which I guess again something is a topic which you might be knowing. I'm talking to the Form 8 students. All the viewers may or may not be aware of this thing. So yes, These are the main topics which will be covered during your whole Form 9 curriculum. This was not just the box of physics, it was actually your whole curriculum of Form 9. And I'm looking forward for such kind of things, such kind of experiences with you. And these are the 5 chapters which will be there: motion, laws of motion, then gravitation, work, power, energy, and we'll be having the last topic as sound. So it's going to be fun, just the way every science class used to be. All right. Now I'll be opening some points. I'll be opening some time for any queries. Since the chat box is on, you can post your queries right away, and I shall be answering it right away. Yes, I've got one question from Kabir. Used to be in my class, and yes, Kabir, I've got your question. He asks that if by some chance gravity does not work, then also the atmosphere would also be displaced into the space. Yes, definitely. If even for an hour, if the gravity does not, it stops working, and if it takes a time out, a vacation for itself, then we will be in deep trouble. The things which will be moving, the things which will be going away, one of the things will be the atmosphere itself, and we won't be able to probably get it back. So yes, definitely. There is one more question of a person, a student named as Aditya, and the question is, what is Mach speed? MACH. Okay, now the Mach speed is something which is widely used into the Air Force and into the fast moving planes, aircrafts. And 1 Mach means the speed of sound. That is 1 Mach. So if you just convert it, it will be 1300, roughly 1330 kilometer per hour. And that is known as 1 Mach. So if suppose a person says that this aircraft top speed is 0.5 Mach, that means it is the half of 1330 kilometer per hour. So that's how the Mach speed is calculated. So I'm waiting for more questions for next 3 minutes. I can see around 40 people are watching, but you need to post some questions for me, and that's how it will be more of interactive session. So ask any questions related to physics. Okay. Since we have not received any new questions, so we shall end over here. I hope you had a wonderful time about unboxing physics, and keep exploring, keep looking into the in terms of physics. Physics is very beautiful. You will be able to see in every sports. You'll be able to see every place that you are doing. Even if you are just putting your tripod in some angle, there is also physics. If you are playing any sports, that is completely physics. Whether it's badminton or any other racket sport, or if it is anything else, it is physics. And if you have liked, or if you have just understood whatever I said, then you can like the video, as well as I'm getting, okay, just a minute, I need to hold on. I've got one more question about it. What Bhavya is asking, what does supersonic means? Now, well, Bhavya, supersonic means which is faster than sound. So anything which is moving faster than the speed of the sound in air, that will be known as supersonic. The supersonic jets, that's how basically you might have known the word. Those aircrafts are moving as fast as the defense aircrafts are moving as fast as 1400, 1800, 2200 kilometer per hour. So yes, that is the supersonic jets. I hope I have made your afternoon quite scientific and quite physics oriented. It was lovely having you all, and thanks a lot.